So warm up for today. Question 1, find the average rate of change. Average rate of change. Hopefully you remember what that is. Part 2, find the location of C such that the derivative equals the average rate of change, or the instantaneous rate of change equals the average rate of change. Are we okay getting started on that, or you need some prompts, some nudges in the right direction here? Some nudges. Like, yes, give me a nudge. What's average rate of change mean? Algebraic slope. So that's just good old y2 minus y1 over x2 minus x1. That's algebra rate of change, or average rate of change. Calculus rate of change, instantaneous rate of change, would be the derivative. So you'll set the derivative equal to whatever you get for number 1 and figure out where that happens. So step 1, find the average rate of change. Step 2, where does that happen? So it'll be an x value. So maybe that's enough to get you going. Fairly straightforward. So I need f of 1. 1 squared minus 3 is negative 2. F of 4. 4 squared minus 3 is 13. So good old algebra 1 slope. Average rate of change is 13 minus negative 2 over 4 minus 1. Remember, the order you do them in doesn't really matter as long as they're corresponding with each other. So 13 minus negative 2, 4 minus 1. So 15 over 3. So the average slope from 1 to 4 is 15 thirds.
Or 5.
What's that?
Or it could be 5.
Yes, also known as 5. Man, I'm so used to safe stopping, I don't even reduce fractions. Yes, 5. That'd be even better. So average slope from 1 to 4 is 5. Next question says, find where the instantaneous rate of change, so the derivative f prime of x would be 2x, and we want to know where that equals the average rate of change, so that would be at 5/2. How this relates to anything is that what we just used or showed was the MVT for derivatives. Because 5/2 is in between, or is on 1 to 4. So MVT for derivatives says that the calculus slope somewhere is equal to the algebra slope for the whole thing, and that this C is on A to B. That's the MVT for derivatives. Yesterday we did MVT for integrals. It said that the average value, or the location of the average value, is also on the interval. So they're related. Like C is on A to B. That's how they're related, the two MVTs. One is about derivatives. One is about integrals, or average value area. All right, so this is just old stuff, but MVT is important. So since we said it yesterday, I wanted to see it again.